All right, welcome back to another module of the Mass Spec Coding Club. On the last one, we talked about how to import a FASTA file, and we used the PyDiomics library and loop to each row, and just basically looked at description, sequence. We then imported our own calc mass function so we could calculate the mass. What I want to do now is basically think about how we would take this and write it out, right? So we could basically write this into like an Excel sheet that we could then read in, and we'll talk about that later. So one of the things we wanted to do is maybe parse that description a little bit. So you can see the description is, if we take off the mass and rerun it here, is this long line, right? And you can see there's clear ways that this is broken up, but it's a single string. So let's talk a little bit about string operations and how we can use that to split and isolate these different things. So one of the major functions here that we want to use is something called string.split. And so what that lets us do is split strings based on their different characters. So one of the things I noticed first is that if you look here, this begins with these vertical lines as ways to break the database name, and then this identifier here, and then this other identifier. I had to look up here to see what all these things, so this is the unique identifier and the entry name, the protein name, those sort of things. So let's go ahead and break that up. So what we'll do is we'll say the description.split, so that'll split the string, and we're going to split it by that vertical line, right? And what we're going to see when we print this is that it now splits out the database name, this unique identifier, and then the entry name starts the split. But this is all one giant string here. So what we could do is something like, let's take this out of the print. So we're going to parse this in a couple different ways. We'll say db name, UID, and we'll just call it the description 2. And we'll say that's equal to this split. So now when we print, we have the DB name, UID, and the description 2, right? You can see we've split them all into the different components, right? So the description 2, though, is something we need to unpack a little bit more. Let's run that. You can see the description 2 now has this. So the first thing I notice is that now the thing that's split is the spacing, right? So the space now splits it. But the problem here is that now we get this whole thing, right? And this is, there's spaces in the name of the protein, and that's going to cause issues, because if we just do this dot split and split it on a space, you can see it's splitting the protein name as well, low density lipoprotein receptor related protein, right? Those things shouldn't be split. So one way that we can do this to help with some of this is we can put a (1) here in the split. What that tells it is basically only do a single split. So it's going to go to the first space, split it there, and then that's going to split so that we get the name here, and then we get the protein name. You can see the thing that always follows the protein is this OS, right? So what we could do would be to say, let's take this back out, and we'll say entry, comma, description 3 equals this, right? So now the description 3 is going to be everything after, right? And of course we could then say description, we'll say p name, protein name, comma, description 4 equals description 3 dot split, and we'll split it on space OS, right? Yeah. And let's just go ahead and put in the 1 just in case there's something there. Now if we put in p name, right, now what we're getting out are clean protein names, right, that are coming in, right? Okay, so that's a way of parsing those FASTA descriptions. Now what we need to do is collect those into something that we can write. So we've got all these different things that we've pulled out, and of course if we want to pull out other things about the organism, we can also pull those out with the same sort of string splitting operations and those sort of things. What we're going to use to do that is a library called Pandas, and Pandas is an excellent library. It's useful for a lot of things, but you could think of Pandas as sort of like Excel for Python, right? So if you're used to using Excel, Pandas will feel very familiar. It has columns, it has rows. It's meant for tabular data, right? Meaning sort of two-dimensional Excel sheet sort of data. So we're going to go ahead and import Pandas as PD. That's a common way to name it. If you don't have Pandas installed, of course, hop over to the terminal, type pip install pandas. If you want to read and write Excel files, you might also need to open, I think it's called, like it might be PyOpenXML or Py or even OpenXML or something. If you're trying to read and write Excel and it says, no module found there, Pandas should be able to do it, but you might need to install that other module. So take a look and try it. I've already done it on my computer. There's lots of different ways to use Pandas. And so what I would recommend, we won't get into all of it here. I would recommend doing some tutorials separately if you're using it a lot. For me, I find that it's easiest to create columns and then add them to your data frame after. You also can create rows and then add those to your data frame. But I don't know, for me, it's more intuitive to add them as like long columns. So what we're going to say is let's use, we'll say entries, and we'll just create a blank array, and we'll say p names, create a blank array, and we'll say masses, create a blank array. So what we're then going to do is every time we loop through it, we're going to say entries.append entry, and we'll say p names.append p name. We'll say masses.append mass, right? So basically what we're doing is we're creating these long lists. Every time we loop through, we're adding to each of those lists. Now they're all separate columns, but what we can then do is say the data frame df equals pd.dataframe, right? Then what we need to do is start putting in the different things, and I didn't do this ahead of time, so I'm going to try and make sure I can get this right. Actually, I'll just create an empty data frame, and then we'll see df, and we'll call this entry equals entries, df protein name equals p names. We'll say df masses, or mass, equals masses. So then we'll do print df, and that'll print our data frame. So let's go ahead and run this. Now you can see how this is printing out, right? It looks sort of like an Excel table. We're missing the middle, but you can see the header is entry. We have all our entries, and p name would be there, and then mass, we have our masses. Actually, it looks like we have a bug. I'm a little bit concerned we have a bug in our masses because it looks like all the masses have exactly the same value. Let's go back and take a look. So the problem is that the sequence wasn't actually used there. So that fixes the bug there. So it was using the test sequence every time. Let's go back now. Let's rerun this. So actually the bug, oops, lots of unrecognized characters. The bug was actually in our mass calculation function. So we fixed that now. Now we've got everything coming out here. This is going to have, well, let's just take a look. So now let's go ahead and we'll do df.to Excel, and we'll say mass table.xlsx. If we run this, it's going to say there's some unrecognized characters. These are coming in from the sequence, but we've now created this mass table file. I'm going to open this in the Explorer so that we can open it up. We'll open Excel, and you can see we've got our entries, we've got our protein names, and we've got our masses, right? So this is basically how we can take a FASTA file, loop through it, do sort of various different things, and then write it as an Excel file. And so next time what we'll do is we'll talk about how you could read in an Excel file, calculate all these different things, and spit it back out into another Excel file. All right, thank you.